Hello, so in today's class we will look at case 3 where the roots of the characteristic equation are real and equal. So we will look at what are the two linearly independent solutions of the homogeneous system when you have characteristic equation having real and equal roots. So if you have the roots lambda 1 and lambda 2, say both are equal to lambda. So if you take x equal to a e raised to lambda t and y equal to b e raised to lambda t, this is going to be a solution. You need to find a second linearly independent solution. ODE repeated roots you multiply with x in that case. So if x equal to m equal to 1 1 anengil nammal solution edumbo e raised to x e raised to x. So here we can think of a solution of the form at e raised to lambda t and y equal to bt e raised to lambda t. So here when you have this particular case, your solution is going to be of the form but instead of this your solution will be in the form a1 t plus a2 e raised to lambda t and y will be some b1 t plus b2 e raised to lambda t. So this is going to be the solution or going to be the second linearly independent solution when you have real and equal roots. നമുക്ക് എല്ലാ കേസിലും എപ്പോഴും രണ്ട് ഇൻഡിപെൻഡൻറ്റ് സൊല്യൂഷൻസ് കിട്ടണം എന്ന് നിർബന്ധമില്ല. So sometimes when you solve the equation there you will have only a single solution. So we will look at what are the conditions for the second linearly independent solution to occur. So let us see the theorem. So the theorem says that if the roots lambda 1 lambda 2 of the characteristic equation are real and equal, say you have lambda 1 equal to lambda 2 equal to lambda, and further assume that the system is not such that a1 equal to b2 not equal to 0 and a2 equal to b1 equal to 0. So when you have this case, there you will have only a single solution. So we assume that system is not such that a1 equal to b2 not equal to 0 and a2 equal to b1 equal to 0. Then the system will have two linearly independent solutions. So solutions will be of the form x equal to a e raised to lambda t and y is b e raised to lambda t, and the second linearly independent solution is a1 t plus a2 e raised to lambda t and y is b1 t plus b2 e raised to lambda t. So here a b, a1, a2, b1 and b2, they are fixed constants, and these will satisfy a condition that b1 by a1 must be equal to b by a. So when we find the solution ആവണമെങ്കിൽ അത് ഈ കണ്ടീഷനും കൂടി സാറ്റിസ്ഫൈ ചെയ്യണം. സോ b1 by a1 will be equal to b by a provided a1 and b1 are not both 0. So a1 and b1 both will not be equal to 0. So a1 ഉം b1 ഉം രണ്ടും 0 ആണെങ്കിൽ you will get again solutions will be dependent in that case. So you will have b by a equal to b1 by a1 and a1 and b1 are not both 0, and the general solution will be of the form, so that will be the linear combination of both the solutions. So x will be c1a e raised to lambda t plus c2 a1 t plus a2 e raised to lambda t, and y will be c1b e raised to lambda t plus c2 b1 t plus b2 e raised to lambda t, where c1 c2 are arbitrary constants. So this is the form of general solution when you have real and repeated roots. So we will see an example how to solve a system of equation when you have repeated roots. So let us find the general solution of dx by dt equal to 4x minus y and dy by dt is equal to x plus 2y. So assume that, so we'll start with x equal to a e raised to lambda t and y equal to b e raised to lambda t. So we need to find the characteristic equation, the solution of the system. So you will get a lambda e raised to lambda t equal to 4a e raised to lambda t minus b e raised to lambda t, and b lambda e raised to lambda t is equal to a e raised to lambda t plus 2b e raised to lambda t. So that will give us a into 4 minus lambda minus b equal to 0, and you will have a plus b 2 minus lambda equal to 0. So a non-trivial solution exists if the determinant is equal to 0. So you have determinant of, so we have determinant 4 minus lambda minus 1, 1 and 2 minus lambda. So that must be equal to 0. So you will get 8 minus 6 lambda plus lambda square plus 1 equal to 0. So that is lambda square minus 6 lambda plus 9 equal to 0. So the roots are 3, 3. So the roots are real and equal. And now next is to find a and b. So നമ്മുടെ ആദ്യത്തെ ഇക്വേഷനിൽ എയും ബിയും ലാംഡ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്യുക and find out the value of a and b. So lambda is equal to 3. അപ്പോൾ ഇവിടെ a minus b വരും ആദ്യത്തെ ഇക്വേഷനിൽ, രണ്ടാമത്തെ ഇക്വേഷനിലും 2 minus 3 എടുക്കുമ്പോൾ minus 1 വരും. So again the second equation is a minus 3. So lambda equal to 3 gives a minus b equal to 0. So let us take a equal to b equal to 1. So we have got a and b. So therefore the first solution is e raised to 3t and y equal to e raised to 3t is a solution of the system. Now the second solution, so the second solution is x equal to a1t plus a2 e raised to 3t, and y will be b1t plus b2 e raised to 3t. And now if this is a solution, it must satisfy the given equation. So let us substitute x and y in the linear system. Okay. So the system is dx by dt equal to 4x minus y, and dy by dt is x plus 2y. ഇനി നമ്മുടെ x എന്ന് പറയുന്നത് a1t plus a2 e raised to 3t, and y is b1t plus b2 e raised to 3t. So let us take the derivative first. Appo derivative will be 3a1t plus 3a2 plus a1 varum e raised to 3t. So that will be equal to 4 a1t plus a2 e raised to 3t minus b1t plus b2 e raised to 3t. And the second equation will be again 3b1t plus 3b2 plus b1 e raised to 3t, that will be equal to x a1t plus a2 e raised to 3t plus 2 b1t plus b2 e raised to 3t. So e raised to 3t will cancel off on both sides. Now okay, so when you simplify the equation, അപ്പോൾ t വരുന്ന ടേംസും കോൺസ്റ്റൻറ്റ് ടേംസും ഒരുമിച്ചെടുക്കുക. അപ്പോൾ you will get 3a1 minus 4a1 minus b1t plus 3a2 plus a1 minus 4a2 plus b2 equal to 0 varum, and 3b1 minus a1 minus 2b1 plus 3 into t plus 3b2 plus b1 minus a2 minus 2b2, that will be equal to 0. So upon simplifying, so you will get minus a1 minus b1 t plus you will have a1 plus so you will get a1 plus b2 minus a2 equal to 0, and the second equation you will get 3b1 minus 3a1 t plus b2 so you will have b2 plus b1 minus a2 equal to 0. So here there was a mistake in the first equation. ഇവിടെ 3a1 minus 4a1 plus b1 ആണ് വരിക. ഇവിടെ plus b1 വരും. So that will give us b1. Okay. So therefore you will get, okay, let us write the identities one again. So you will get, so I can rewrite it as a1 minus b1 t plus a2 minus a1 minus b2 equal to 0, and again a1 minus b1 t plus a2 minus b1 minus b2 equal to 0. So these are the two equations we are getting. Now this equation, from this equation, so we will get a1 minus b1 equal to 0, and you have a2 minus a1 minus b2 equal to 0, and a2 minus b1 minus b2 is equal to 0. So a1 minus b1 equal to 0 gives, so let us take a1 equal to b1 equal to 1, and again from the first equation, so a2 minus b2 is equal to a1, and that is again equal to b1. So therefore we will get a2 minus b2 equal to 1 വരും. ഇനി ഇത് 1 വരുന്നത് പോലെ നമുക്ക് a2 ഉം b2 ഉം ചൂസ് ചെയ്യാം. So I can take a2 equal to 1 and b2 equal to 0. ഇനി നമുക്ക് ഇവിടെ വരുമ്പം പല ചോയ്സ് ഉണ്ട്. ഓക്കെ, a2 ഉം b2 I can take it as 3 or 2, അല്ലെങ്കിൽ I can take 4 or 3. അപ്പോൾ അതിനനുസരിച്ച് നമ്മുടെ ജനറൽ സൊല്യൂഷനിൽ വ്യത്യാസം ഉണ്ടാവും. ഓക്കെ, സോ a2 and b2 has many choices here. So all the solutions for all those choices are correct. നമ്മൾ ജനറൽ സൊല്യൂഷൻ എഴുതുമ്പോൾ നമ്മൾ ഇത് നമുക്ക് ഡിഫറെൻറ്റ് വേസിൽ എഴുതാം. സോ അതിനനുസരിച്ച് നമുക്ക് കിട്ടുന്ന ഫങ്ഷൻസ് എല്ലാം സൊല്യൂഷൻസ് ആയിരിക്കും. ഓക്കെ, സോ therefore the solution will be x equal to a1, അപ്പോൾ t plus 1 e raised to lambda t കിട്ടും, or e raised to 3t കിട്ടും, and അതുപോലെ y will be b1t, അപ്പോൾ t plus 0 വരും, t e raised to 3t. Again if you are taking say a2 equal to 3 and b2 equal to 2, അങ്ങനെയാണെങ്കിൽ നമുക്ക് രണ്ടാമത്തെ സൊല്യൂഷൻ വരുന്നത്, ഓക്കെ, ആദ്യത്തെ സൊല്യൂഷൻ a1, അപ്പം t plus 3 വരും, e raised to 3t, and second solution will be t plus 2 e raised to 3t. So that will be the second solution. ഇനി അതുപോലെ ഇവിടെ നമുക്ക് a1 equal to b1 1 എടുക്കണമെന്ന് നിർബന്ധമില്ല, 2 എടുക്കാം. അങ്ങനെയാണെങ്കിൽ ഇവിടെ രണ്ടും, ഇവിടെ 2t വരും, ഇവിടെ 2t വരും. So that is up to our choice. So therefore we will get this as the second solution. Okay, and now our first solution is, so a and b were equal to 1. Okay, so therefore the general solution is, so x is equal to c1 e raised to 3t plus c2 t plus 1 e raised to 3t, and y is then c1 e raised to 3t plus c2 t e raised to 3t. So that is the required general solution. So here c1 and c2 are arbitrary constants. So that is the arbitrary constants. So that is the form of solution when you have repeated the roots. So the second solution will be a1t plus a2 e raised to 3t, and y equal to b1t plus b2 e raised to 3t. Other equation substitute ചെയ്ത് a1 a2 b1 b2 ന്റെ values കണ്ടുപിടിക്കുക. So that will give us the second solution. So with that we will conclude today. So you see few more problems in the next class.